Dear students, today we will have one more delight to learn drawing as one of the mass transfer operation. Let us have a look at the types of the moisture content in the wet solid. It's equilibrium moisture, then free water, bound water and unbound water. These are the four most basic types of moisture contents in wet solids. Let us have a look at the definitions of each of these types. First, equilibrium moisture. To know the definitions of all these types of moistures, let us have a look at the concept of drying first. Here for an example, I have taken an example of wood. This wood contains 35% moisture and the relative humidity of the wood at 35% moisture is 100%. I hope you know the concept of relative humidity because this is the most basic concept as a background to learn drying. The wet wood with 35% moisture having relative humidity 100% is brought in contact with air. The air whose relative humidity is 60%. Relative humidity of air 60% means the partial pressure of water contained in air is equal to 60% of vapor pressure of water, and 100% relative humidity of wood means partial pressure of water in wood is equal to vapor pressure of water at any specific temperature. So naturally, partial pressure here in wood of water is equal to vapor pressure, and partial pressure of water here in air is 60% of vapor pressure. So naturally there will be evaporation of water contained in wood as moisture. As soon as it evaporates, it mixes with the airstream and goes away. In this way, drying occurs. That is the mechanism of drying. How it is related on this graph? Let me tell you, this graph is relative humidity versus X, that is kg moisture per kg of dry solid. This is the curve. Here it is point. Let me explain the curve first. Wood with 35% moisture content having relative humidity 100% is represented by point A on the curve. The drying is taking place along the curve A, B, C, C dash and D. Of all the points on the curve, the initial condition of the wood with 35% moisture, 100% relative humidity is point A. The drying began at point A where the moisture content is 35%, means 0.35 kg moisture per kg of dry solid. The drying process commences. The air with 60% humidity is allowed to flow over the wet wood. Wood is just an example. You can take any material in place of wood. So air with 60% relative humidity is allowed to pass over wood having 35% moisture, and the condition is represented by point A on the curve. After some time, some water will evaporate. There will be loss of moisture. But with that amount of moisture loss, still the relative humidity of the wood will remain 100%. And this will be represented by point B on the curve. Drying is going on, but the relative humidity of the wood is still 100%. This means that wood is highly moisturized. At point B and beyond point B up to A, the vapor pressure of the moisture contained in air is equal to its partial pressure. This is the condition represented by point A. Point A to till point B. This is the condition. What is that condition? PA bar means partial pressure of water contained, moisture contained in wood is equal to its vapor pressure, means water's vapor pressure. This is the condition represented between points A and B. Though there is loss of moisture, the relative humidity remains 100% between point A to B. So this moisture contained related to the segment AB of the drying curve is known as unbound water. We will learn the definition of equilibrium moisture content as soon as we go down the curve. So first, at this condition, it's unbound water. So how can we define the unbound water in moist material, in wet material? It is the water contained in the wet material whose partial pressure equals to vapor pressure. And all these unbound water would be represented by all the concentrations from B onwards towards A. Unbound water. सोप्या भाषेत सांगायचं झालं तर अनबाउंड वॉटर हे ते असतं की जे त्या सॉलिडली घट्ट पकडून ठेवलेलं असतं. आपण म्हणतो ना की एखादी गोष्ट पचपच ओली झाली आहे, तर ते पचपचणं जे असतं ना ते म्हणजे अनबाउंड वॉटर असतं. म्हणजे एखादी गोष्ट जेव्हा ओली होते त्यावेळेस ती पचपचायला सुरुवात होते, मग त्याच्यामध्ये आणखी आपण वॉटर ॲड करत गेलो तर ती आणखी पचपच होत जाते. तर हे रिजन आहे ते फ्रॉम पॉईंट ए टू बी. जेव्हा ही ड्राइंग होते बिटवीन द पॉइंट्स ए अँड बी, इट इज जस्ट सिमिलर टू the evaporation of water from the free surface of water kept in a pot, in a vessel, in a container. एका कंटेनरमध्ये जेव्हा आपण वॉटर ठेवतो त्या वॉटरच्या सरफेसवरून जे इव्हॅपोरेशन होते, मॉइश्चरचं वॉटरचं लॉस होतं, सेम कंडिशन इज ॲप्लिकेबल हिअर इन टर्म्स ऑफ 100% humid solid when the condition is PA bar is equal to PA bar star. So that is unbound water. And then remaining is the bound water. So the total moisture minus unbound water is equal to bound water. But there is a speciality of bound water. You are able to see from B onwards along the curve, the relative humidity is going down. The relative humidity of wood is going down. It means that partial pressure of water content in wood is not equal to vapor pressure of water. It is going down. Partial pressure is going down because partial pressure is directly related to the concentration of any component. Here the component is moisture, water. So water is going to air. This water is going to be, water is, the concentration of water is going down in the wood due to loss by drying, by evaporation. So partial pressure is going down now. Therefore the curve is coming down. So what is the condition here to define bound water? It is the water contained in the wet solid. It is the moisture contained in the wet solids whose partial pressure falls below the vapor pressure. Whose partial pressure falls below the vapor pressure of water contained in the wood at that specific temperature. That is the condition for bound water, which is the definition of bound water. It is the water contained in the wet solid whose partial pressure falls below vapor pressure. Furthermore, in the curve, as we go down, we reach point C. Point C. Point C, if you are able to see, it is related to 60% humidity. 60% relative humidity. What happens at 60% relative humidity? Air's relative humidity is 60%, means its partial pressure is equal to 60% of vapor pressure. If wet material's partial pressure falls down, and because of which the relative humidity of the wet solid becomes 60%, partial pressure falls down because moisture is lost. So we arrive at point C, which is related to 60% humidity of the wood system. It means that the partial pressure is now 60% of the vapor pressure. This is the condition represented by point C. If this PA is equal to 60% of vapor pressure of the moisture of water, if air is also having partial pressure equal to 60% PA, means an equilibrium is set now. At point C, the equilibrium is set. Right? At equilibrium, we know there is no appreciable mass transfer. What does it mean? It means we can dry this wood with 35% moisture content by using 60% relative humidity air only up to 60% humidity of wood. Beyond this, we cannot remove the moisture. So whatever moisture we will be able to remove by using 60% relative humidity air is only up to this, from 0.35 to 0.1. Only this much moisture we will be able to remove. The moisture still remain at this point in the wood. That remained moisture is called as equilibrium moisture. This equilibrium moisture cannot be removed further because equilibrium is set. No appreciable mass transfer of moisture of water from wet solid to air is possible. Not possible. So this is equilibrium point, and the moisture represented by this orange line is equilibrium moisture. Got it? What if we use an air for drying whose relative humidity is 40%? Naturally, this curve will go down again, and the point C will be shifted to point C dash. So this will be the equilibrium point, and the equilibrium moisture content at 40% RH of air is this. What if we use 20% RH air? This would be the equilibrium moisture content. For 10% it would be here, and for 0 it would be here. Got it? So we learned bound moisture, unbound moisture and equilibrium moisture. Now what is free water? Free water is that which we can remove from wet solid. Means total moisture content minus equilibrium moisture content would be the free water. This is the free water. It is free to be removed. Why it is free? It is free to be removed. Beyond equilibrium point we cannot remove, but up to equilibrium point we can remove, because the water is free to be removed by drying process. If the air used is 60% relative humidity for this example, if air used would be 40% relative humidity, then the free moisture would be this much. For 30 it would be this much, for 20 it would be this much, for 10 it would be this much, and for 0 whole. So that is how all these types of moistures are defined. I hope you got the concept, right? All the best. Thank you.